known as esters. Now, these are some of the compounds which are responsible for distinctive physical properties in most of the substances that we are aware of, such as the scent of perfumes. Perfumes smell the way they do in a nice way because they contain esters in them. Likewise, if you look at a range of food colors or flavorings, they give a distinctive taste to the food that they are used in, and these are due to the, again, presence of esters. Most of the products that we have on the shelf in the supermarket, they contain esters as a flavor or a preservative. So basically, esters are those chemicals that are used as flavoring agents. Let's say, for example, if we are looking at a fizzy drink. In a fizzy drink, there are a range of flavors like pineapple flavor, strawberry flavor, and so forth. So these flavors are not natural fruit essence. They are chemically synthesized esters which resemble the taste of the fruit they are representing. Esters are also responsible for the sweet fragrance of flowers. So individual flowers smell the way they do in a nice way because of the different esters present in them. And last but not the least, they are also a very important ingredient in essential oils. So we are going to be looking at in this particular topic how we are going to be naming an ester and how we are going to be drawing an ester molecule by reacting alcohol and carboxylic acids together. So if you look at the functional group of an ester, you can see R1, R2 ester. So C double bond O, single bond O, that is a functional group of an ester. This particular part of the ester is coming from the acid. So the acid part of an ester is always drawn first, followed by the alcohol group. So when we are drawing an ester, we are drawing the acid group first, and then we are putting the group of the alcohol. If you look at this example here, so from this example now you can see this is an alkyl group and this is another alkyl group, and in the middle we have the C double bond O and single bond O. So how do you know which part is coming from the alcohol and which part is coming from the acid? Now the alcohol is going to have the name ending with YL. So this is the alcohol part. 2 carbon atoms are in the alcohol. Therefore the name will be ethyl. The alcohol will be ethanol. The carboxylic acid name is going to end with anoate. So the first part that is drawn here, that is a carboxylic acid of the molecule. That's the carboxylic group of the ester molecule. So 2 carbon atoms are there. The prefix is eth. So this ethanoic acid will become ethanoate. So now when we are going to name the ester, we are going to name the alcohol first and then we are going to put the name of the acid. So we are going to write down the name as such. Ethyl ethanoate. I hope you are able to look at the difference in the two different things we have learned here. When we are naming an ester, we are going to name the alcohol group first. And when we are drawing the ester, we are going to draw the carboxylic acid group first. So the first thing we do is to do the division, divide the acid part and the alcohol part. Remember, the first part that is drawn is always a carboxylic acid part and the latter is going to be the alcohol part. So if you look at this end here, starting from the O, that is the 2 carbon atom coming from the alcohol. So 2 carbon atom alcohol is called ethanol. The name of the ethanol will become ethyl. This particular group now is having 3 carbon atoms. So that is a carboxylic acid group. A 3 carbon atom carboxylic group is called propanoic acid. The propanoic acid is going to become propanoate. Okay, so we have propanoate group here, and that's the ethyl group. So when we are going to name, we are going to put ethyl first and then propanoate. So it's ethyl propanoate. Let's see how we're going to name this particular ester down here in the second example. So we do the same thing again. Identify the alcohol. 3 carbon alcohol, that's propanol. So propanol is going to become propyl, while a 1 carbon carboxylic acid is going to be methanoate. So the name is propyl methanoate. When we are drawing ester, we are going to be drawing the acid part first, followed by the alcohol part. So the acid part in this particular name is methanoate, while the alcohol part is the ethyl. So acid has methanoate, that means 1 carbon. So we are going to draw 1 carbon. And then remember, 1 carbon has a double bond O and a hydrogen at the end and a single bond O. So this single bond O is now bonded to 2 carbon atoms. These 2 carbon atoms are part of the ethyl group. So the remaining bond is going to be occupied by the hydrogens now. So this is how you draw ethyl methanoate. So this particular group, that is the ethyl group, and this particular group is the methanoate group. Esters that we are supposed to be knowing. Number 1, their boiling point. They are polar molecules. Therefore, they are going to have dipole-dipole interactions, which means that their boiling point will be lower than that of carboxylic acids. Solubility in water. Small group esters, they are fairly soluble in water, but as the number of carbon atom increase, their solubility is going to decrease. And the reason why the solubility in water of an ester is possible is because esters can form hydrogen bonding with water molecules, as seen here in this particular picture. Through the reaction of alcohol and carboxylic acid. So if we look at this example here, we have a carboxylic acid containing 2 carbon atoms and alcohol containing 1 carbon atom. So when this reaction proceeds, normally we say the acid is going to donate a proton, but in esterification, the acid is going to donate the OH, while the alcohol will be donating the H. So the alcohol group, which is donating the H, and the carboxylic acid, which is donating the OH, is now going to come together to form an ester. The H and the OH will combine to form water, and the remaining group will be ester, starting with the carboxylic group. So we are going to draw the carboxylic group first. The 2 carbons. So we are going to draw the 2 carbon atoms that's remaining from the carboxylic group. Okay. Now this particular carbon will then be bonded to the, okay, we draw the remaining hydrogens here, and then this carbon will now be bonded to the oxygen, this oxygen here. So this particular oxygen will now come here, and this will carry the other carbon with it. So this is your ester. Byproduct H2O. So we have methanol, ethanoic acid, Name of the ester will be methyl ethanoate. So students, I hope you have learned how esters are different from the other molecules and also how esters are named and drawn based on the different rules that we have just learned.